This is question 3 that I set as part of the test, but I said I wanted you to do it for homework. It's quite a long question, and it's quite involved, and again it's difficult to start and know how to work your way through the problem. So I'm going to record this video now so that if you're struggling at home, then you can watch it and have a chance of completing it. As usual, don't just watch it, try and work through it with me, and when you think you know enough to continue on your own, just stop the video, finish the question, and then start the video again to see whether it's right or not. So we've got a toboggan, and it's accelerating down a hill with a gradient of 28%, and they explain what that means in the question straight afterwards. At the foot of the hill, the ground flattens out horizontally, and the toboggan comes to rest in 40 meters after 10 seconds. And we need to find the speed at the bottom of the hill and the value of the coefficient of friction. Now this is the type of question that with experience you realise is a two-stage problem. You've got a toboggan sliding down a slope, and then it reaches the slope at a certain speed, and then it continues at that, well, that's its initial speed for the horizontal part of the journey, where it finally comes to rest. So there is friction between the toboggan and the surface, so it's not frictionless, and we need to find the coefficient of friction. Now, with experience, you realise that actually we want to split this into two bits, and to find the speed at the bottom of the slope, it's better to think about the flat part of the problem than it is to think about the toboggan on the slope. Now that's something you may not have considered doing, and another reason why you've got to do as many questions as you can, and every time you get stuck, come and ask for help or pointers so that we can help you gain the experience you need to problem solve this type of issues. So I'm going to just draw a very simple model for the toboggan, and it's got initial speed u, and that was produced from sliding down the slope. But it didn't matter that it was produced from sliding down the slope. That's just the initial speed for this part of the model, and it's going to have a final velocity of v, and we know it comes to rest in 40 meters after 10 seconds. I'm going to declare the acceleration to be in that direction, although I know it's going to come out as a negative number, so I'm not going to be worried when I get a negative number. In fact, I expect a negative number. And friction is going to be in this direction because it's opposing motion, and motion is in that direction. Now, a toboggan is not driven. There's no power. There's nothing driving it forward. So they are the only three forces on this diagram. Now we don't know the weight or the mass of the toboggan, so I'm going to call it mg, and the contact force is r. Now, a lot of students will look at this and say, well, the question's wrong, we don't know the weight of it, we don't know the mass of it, so we're just going to have to work with that and see what happens. So the first thing I'm going to do is work out the acceleration using my Suvat equations. S, U, V, A, and T. Now S is the displacement, which is 40 meters. I'm going to take to the right to be positive. So to the right is positive, so that's going to be 40 meters. I don't know U. I do know V is 0 meters per second. I'm looking for A, so I'm going to call it A, and I'm told T is 10. So we've got to get to A using those four values. Now, it's the least used of the Suvat equations, which I'm going to use, but it is important to try and remember it. S is equal to Vt minus a half At squared. A lot of people use S equals Ut plus a half At squared, but they forget this one. And in this case, we know that S is 40 meters, V is going to be, the final velocity is 0, so we're going to get minus A equals 10 squared because the time is 10. So we get 80 equals minus A times by 100. So A is minus 8 over 10, or minus 4 over 5 meters per second to the minus 2. And again, I was expecting a negative answer, so I'm happy with that. So the acceleration equals minus 4/5 meters per second to the minus 2. Now the reason why I needed the acceleration is because I will need to work out the coefficient of friction at some point. So I will need the acceleration when I do that part. But I'm going to use that acceleration now to find the initial speed for this part of the problem, which is the speed of the toboggan at the bottom of the hill. So now I've got a equals minus 4/5, so I can choose a number of different formulae. So you've had equations, but I'm going to use v equals u plus at. So 0 equals u minus 4/5 of 10, because the final velocity is 0 after 10 seconds. So u equals 8 meters per second to the minus 1. So the speed of the toboggan at the bottom of the slope is 8 meters per second. Now I'm going to resolve my forces to find the coefficient of friction, because I know that the coefficient of friction is equal to friction over contact force. So if I can find the frictional force and I can find the normal contact force, then I can also find the coefficient of friction. So I'm going to resolve parallel to the slope to begin with. I'm going to take that direction as positive, and we're using F equals ma. So if I'm taking that way as positive, I get minus friction equals m times by minus 4/5, because acceleration is also negative if I take to the right as positive. So I get friction equals 4/5 of m. Now I'm going to resolve perpendicular, which is up in this case. Take up as positive, F equals ma again, and I get r minus mg equals 0, or r equals mg. So mu equals 4/5 of m divided by mg, and that's why we didn't have to worry about not being given a mass in this case, because the masses cancel, and we get 4/5 divided by 9.8, which is 0.081632. So I can say that mu is 0.816 to 3 significant figures. So I've worked out the initial speed for this particular part of the problem, which is the same as speed at the bottom of the slope, and I've also worked out the coefficient of friction. So I've completed the first part of the problem. Now it says, assuming the coefficient of friction is the same throughout the ride, find the... So now we're going to look at the second part of the same problem, and what I'd like you to do is draw a model of the toboggan on the slope and get as much information as you can on that as possible, and then we'll compare our diagrams. Okay, right, here's my slope, and the toboggan starts with an initial speed of 0, and at the bottom of the slope it's going to be with a speed of 8 meters per second. It's going to be accelerating down the slope, but it's not going to be accelerating in the perpendicular direction. So particle is in contact, so it's have a contact force of r, and it's going to have a weight of mg. Now we don't know what m is, so don't think this problem's not doable. We're just going to have to go for it, see what happens. We've got an angle theta, and we've got a frictional force acting up the slope, opposing the motion which is down the slope. So if you look at that again, because the diagram is slightly off the paper, here's my contact force, it's perpendicular, here's my weight acting down, defined in terms of mg. Now we do know that sine theta equals 28 over 100. So if we draw the triangle, we know that's 128 like that. And we can work out this side using Pythagoras Theorem. So work out the adjacent side so that you can also work out cos theta. Pause the video. And you should have got the adjacent side was 96. And if you didn't, it's because you added these together. Now it's, remember, it's the hypotenuse squared, take away the short side, not add the short side squared, or square rooted. So now we've got cos theta equals 96 over 100. So we've got everything we need when we come to resolve. And that's what we're going to do next. So I'd like you to resolve parallel to the slope, taking down to be positive, and using f equals ma. Pause the video. Okay, well hopefully you got mg sine theta minus the friction is equal to ma. And sine theta equals 28 over 100. So we can write that as 28 over 100 mg minus friction equals ma. And we can cancel that fraction down if you like, but don't need to. Now we're going to resolve perpendicular direction, because what we're going to be using is the fact that friction is equal to mu r, so we need r that we can times by the mu that we worked out from the first part to get friction to go in here. So resolve perpendicular, take out to be positive, using f equals ma, please, and remember that a is 0 in this case, so do include it, don't leave it off. Pause your video. Okay, so we've got r minus mg cos theta equals 0. So r equals mg cos theta, or 96 mg over 100. So if we now substitute that in to the equation fr equals 0.8, so 0.8, or was it 0.08? 0.08. So I made a mistake when I wrote my answer across on this one. Like 0.8 was a bit big. It was 0.08. I'm sure you all spotted that. Now, you can do that in an exam as well. If you spot a mistake you made, because you think, hang on, that seems a bit big, then you can always look back in your workings and change any bits you did in your exam, earlier bits. So 0.081632 multiplied by 96 over 100 mg. And that's what we can then substitute into the equation here. And we get 28 over 100 mg minus 0.8, did it again, 0.81632, lots of 96 over 100 mg equals ma. Now this is why we didn't have to worry about the masses not being given to us, because the masses are in every term here, so they can cancel. So m divided by m is 1, m divided by m is 1, and m divided by m is 1. So we're left with 28 over 100 g minus 0.08, got it right at last, equals a. Put that into your calculator and you'll get the acceleration. And I get a to equal 1.976, or a equals 1.98 meters per second to the minus 2, acting down a slope as defined in the diagram. Now it looks like feels like we've done a lot of work, so we could think we should move on to the next question now. But always go back and read the question, and you'll see that we've got one last part, which is to find how far up the hill the toboggan was to begin with. So pause the video if you think, and well, do the SUVAT part at the end on your own, and then start the video again to check your answer. So S is what we're trying to look for. The initial speed is 0, the final speed is 8, the acceleration is 1.9876, and I'm going to, and t equals, well, we don't know, so again we're going to use v squared minus u squared equals 2as, so we get 8 squared minus 0 equals 2 lots of 1.976 s, so s is 64 over 2 lots of 1.976, which you can work out again, which is 16.19 meters or 16.2 meters. So that's the last part of that question. So hopefully you get the same answer. If not, we can discuss it next lesson.